In a prior chapter of this playlist, I introduced you to a bare-bones circuit that can log data to an Internet of Things website known as ThingSpeak using cellular networks. I'll now explain how to add a battery, solar panel, and a Solar-Lipo Charger in a NEMA certified enclosure so that you can transmit environmental data from a remote location exposed to the elements and with little need for maintenance. The parts for this build are in the description of this video, and the process is broken out into 12 steps. This first step mirrors guidance provided by Adafruit in the Learning section of their website for the Feather Fona. Feel free to skip this step if the headers on your Fona are already soldered, but don't forget to cut the keypad on the back of the Fona for software control of its power state. If you need further details, please advance to minute 9:12 of this video. Morning, folks. Here's our Solar-Lipo batteries being charged by their respective LiPo chargers and solar panels. We've got 8 that we're getting ready to deploy in the field right now. They're 2500 milliamp hour batteries. Underneath each one of those solar panels, I'm trying to keep them out of the sun. And I started charging these at 845, and they had a voltage of 3.98 when I first plugged things in. So checked them all. They all had the same voltage. They've been in storage for quite a while now. So 845, and let's take a look at, see if I can show you what they're. There you go. You can see a little light, a little orange light that says that the battery is charging. And again, the batteries are underneath the solar panels to keep them out of the sun. I'll show you what they look like. So that's one of them right there. That's a 2500 milliamp hour battery, probably more than I need. But I've gone the other way. I've gone as low as 500 milliamp hour, and they've only lasted for about 3 months. And then the 2000 milliamp hours lasted 9 months. So it'll be interesting to see what these 2500 milliamp hour batteries do before I have to do any maintenance on the system. Okay, it's been about 2 hours. It's 10:45 right now. I've been checking on these about every half hour to see how they're progressing. And it looks like the batteries are now charged. If I put some shade on this one, you can see that the green light, which is the done light, shows that the battery is in fact completely charged. The red light you see there is what shows that there's power actually available coming in from the solar panel, and the orange light is charging light. So it took about 2 hours to bring these up from 3.98 volts to full voltage, and looks like they're all working pretty well. These boxes are wonderful. They, they're NEMA certified. They have that nice gasket, which will help make them a little more weatherproof out in the field. The downside to these boxes is that they don't have any kind of a plate to mount your electronics onto. I don't want to mount them on this because I'm going to end up drilling through the box, and that could introduce moisture. So, I have to insert some kind of a plate, and the reseller does have these nice plates that are designed for these boxes that fit right in, but they're kind of expensive. And, for just a piece of plastic, I'd rather see what I can come up with locally. First time I started building these, I went to Ace Hardware and I found this black ABS material. It's about 1/8 of an inch thick. It works great. Downside is you have to cut it with a jigsaw to get a nice cut. So it's a little labor intensive. Then I went to my local hackerspace and I found this material right here, which is, I guess it's sheet PVC. And I found some that was thick and that was real easy to cut with a utility blade. So I decided to see what I could do with that instead. And in fact, this material is nice and stiff. Looks really nice. Just put it right in there, mount my electronics on that. That might be a better alternative to ABS or anything that the manufacturer of these boxes sells, just because it's so cheap and so easy to work with. So just something to keep in mind. One other option is to go with packing material. So I typically don't throw anything away, which drives my wife crazy, but anyway, this stuff is going to end up in a landfill, and I was able to cut it down to size to actually fit inside this box very nicely. The nice thing about this is it's clear, so you can actually see where you need to drill holes to screw it into the back of the box. It's really easy to work with. It's a lot easier to cut than that 16-inch PVC that was had to put some muscle into that, versus this you can just use just a pair of scissors to cut this, and it works great. And not only is it free, you're doing something good for the environment too. So that's certainly a better alternative. Okay, so the next thing I want to talk about is these little RAM mounts and where should you place them. You know, should you put them right here? Should you put them right here? I try to get them as close to the top of the box as possible, because what that lets me do is later on when I mount my solar panel, I can turn this to whatever angle I want without running into the box. So if I were to mount this in the middle, of course this solar panel might run into the face of the box. So in order to you know, be able to work with this, specifically be able to mount this RAM mount on the box and then also epoxy this to the solar panel, we're going to have to take this apart. So be very careful when you do this. There are a lot of little pieces in here, so you want to take careful note, or just refer to this video if something gets misplaced. But just try to, you know, keep everything in the same order. That you found it, so that you can reconstruct it later on. And once that's done, now you can revisit this, and you know, you can either mark it with a pencil or you know, kind of eyeball where the center is, again trying to get it close to the top. One thing I like to do, just because it's quick, is I'll come up, look at this from the top, and I like to use these little punch tools because they're a quick way of marking the plastic. I can go back and see where I need to drill the holes to mount this this ball joint. The next thing we'll want to talk about is how we're going to attach this solar panel onto that ball joint. And I've got one of my older models here to kind of guide us. Ignore this tube right here. This is for a temperature sensor that's located inside the same. For our purposes, it's not important right now. But one thing I want you to pay attention to is look at where I've placed this plastic piece. It's pretty far north on the solar panel, with the power wire on the left side of the solar panel. So what that's going to do is it's going to relieve tension on that cable. We're going to have more of it to play with because this is actually going to get moved back as a result of this being close to the front of the solar panel. So that's going to help relieve tension on this. And the other thing is, if for whatever reason we decide to turn this solar panel completely horizontal like that, it's going to provide us with a little bit of rain protection for that gasket. So it'll, you know, provide us just with a little bit more longevity, hopefully, on the setup. So what I like to use for glue on this is this JB Weld quick weld stuff. This is actually what we've used on an installation that's been out in the field for over a year, and it's held up pretty good. Stuff's pretty easy to use. Let's see. So you just open it up. It might be under a little bit of pressure if it came from a different altitude. Squeeze equal parts inside a little dish. I typically use old jar lids when I've got them around. going to be about 50-50. Now all you do is mix this stuff up. It's going to make this paste, this dark paste. And coffee stirrers from work are pretty good for doing this too, if you have the wooden ones or from the cafeteria. Once you're satisfied, then all you do is take a little bit of this stuff, and we're just going to spread it around. Now all we got to do, this doesn't have to be perfect, but try to get it as centered as you can, close to the top. And that's it. Okay, so in order to finish our box, we're going to have to drill 2 holes. One down here at the bottom of the box to allow for this watertight fitting, and then another one on the side, which is going to allow us to connect our power supply, specifically our solar panel, to that little Solar-Lipo Charger. And for that, we'll use this watertight fitting. We also have this cable gland, so we're going to have to drill holes in the box. So I'll go over that next. Okay, one of the things you want to make sure you do is check the inside of your box and make sure that you remove your electronics before you drill any holes in this box. Okay, so to drill the hole for the watertight fitting on the bottom of the box, what I typically do is just take a ruler, and you can see this little nub right here, which is for the standoff on the inside of the box. That would pretty much be the center. So I can kind of like align this ruler so that it's right above that nub. I'll try to get it in the light. Just kind of centered with that nub. And then, again, I use this handy punch tool to kind of mark the plastic. I'm going to do it 1 inch, 1 inch from where this ruler butts up to the edge of the box right there. And then I've got my little mark right there that's going to guide my drill bit. Or my hole size, I should say. Okay, so in order to make a hole that's big enough to take this watertight fitting, this is 3/4 of an inch, by the way, I'm going to need to use what's known as a hole saw, which is attached to my hand drill. And yes, I could go with a 3/4 of an inch bit, but I found that it when I make it exactly 3/4 of an inch, this is a little hard to get into the hole. So I go a 1/16 of an inch greater, and that makes things a little bit easier. And the really nice thing about using those punches, let's see if I can show you. You see I have that little indentation right there where the light's shining. That makes it real easy to line up the tip of this, I can't see it in the light, line up the tip of this hole saw right into the box. And now I can just go ahead and drill out this nice hole, which is going to accept this watertight fitting very easily now. Okay, once your hole's been drilled, installing this watertight fitting is pretty easy. All you do is you take this little clamp off the top, remove the gasket, and this is going to fit in pretty easy. And then to help create a watertight fitting, we're going to put the gasket on the inside. Don't put it on the outside. We want to put it on the inside because that'll help protect the gasket from any kind of weathering. And then you just take this little clamp and you just screw it on. And make sure this is nice and tight. The more you tighten this, the more that gasket is going to flatten out and create a nice seal. And now we've got a means of inserting sensor wires through this watertight fitting into the box, attach them to the Fona, and encase the whole thing in conduit, and you're good to go. Okay, so the next thing I need to do, of course, is drill a hole in the side of the box right here. And I want that placed so that I can feed the wires from my solar panel that's going to go on this ball joint in through the side of the box into the Solar-Lipo Charger. So the measurements for that are essentially 1 inch from the base of the box and 1 3/4 inch from the top of the box. So what I've done with my ruler is I placed a little mark right here. It kind of gives me a general idea of what 1 inch looks like from the bottom of the box. And then placing the ruler so that it's flush with the top of the box right here. Now what I can do, I'm kind of doing this at a weird angle so I can get it in the camera shot, but now I just need to put this punch tool on 1 3/4 inch. I mark the plastic, and now I know where to place my hole saw for drilling the access hole for the cable gland. Okay, and the bit that I'm going to use on this one is going to be a 1/2 inch hole saw. And using a 1/2 inch with the cable glands that I have listed in the description of this video is fine. I don't have to, even though it's a 1/2 inch gland, I don't have to fight it too much like I did with the 3/4 inch watertight fitting. I don't have to go slightly above. The 1/2 inch will work just fine. So now I'm going to put it right there on that mark that I made. And there you go. And we're good. Okay, so the next thing we'll do is attach this little cable gland to the side of the box right here. Let's go ahead and pull this out of the bag, see what we got. You can see that we have this little gasket, and then we have this cable gland with this little nut on it. So we're going to take this nut off. I'm going to put these off to the side for right now. This is going to fit in that hole pretty easy. We're not going to have any trouble there. So then what you're going to do is take this little gasket, and you're just going to kind of put it around that little male thread, and then this nut, the side with the 3 holes, is going to be the side that screws on. And this one you don't want to over tighten because that gasket is pretty soft, and it'll start to pinch out of the sides if you put too much torque or too much pressure on it. So that's about it. You can see the gasket is creating a nice little seal for us right there that's going to prevent moisture from coming inside the box. And that's about it. Okay, so the next thing we'll want to do is install our base plate with mounted electronics in the box. And you'll recall that I said we need to take this out before we drill those holes. You may be wondering, well, how do I get it underneath these male threads? It's really not that difficult. It's actually pretty easy because this plate is flexible. It drops in fairly nicely. You can get it in there without too much trouble at all. And now we're going to start the process of getting our solar panel ready to mount on the box. The first thing we're going to want to do is get those wires fed through the cable gland and inserted in the terminal block on the Solar-Lipo Charger right there. So let's close this box real quick. You're going to want to make sure that the solar panel is oriented so that the wires are coming off the left. And then you just feed them through this cable gland housing. You can see that the wires are coming right through right there. Okay, one thing you're going to want to make sure to do is to open up these terminal blocks because it's going to make it a lot easier to insert those wires. And of course we're going to want the red wire going into the terminal block that's marked red. And sometimes if you're lucky, you can just push this right in, but most times You actually have to finesse this a little bit. There we go. And now you can take your screwdriver and clamp these back down. And the way you know that, that this is working properly is if you put some light on that solar panel, you'll start to see that little LED right there, that charge LED, come on, which means that there's actually some power going to the Solar-Lipo Charger. So we can see here that, that this is wired up properly. We don't have any shorts or anything anywhere. And the next thing you want to do is tighten this cable gland, because later on we're going to be moving the solar panel around, trying to get it mounted on this ball joint, and we're also going to be putting some conduit, some wraparound conduit on that wire. And if we don't have this tightened up right here, it's going to pull that wire right out of those terminal blocks. So make sure that that's nice and tight. Now I can pull this, and it's not going to do anything as far as pulling those wires out of those terminal blocks. That's not going anywhere. It also creates a nice airtight housing. Okay, so the next part involves actually attaching the solar panel to the ball joint. You'll remember that when I mentioned taking the ball joint apart to basically place all the pieces in such a way that you could rebuild this thing, this is a little tricky too. Basically what you need to do is you kind of need to put this all together at the same time. So you put that part on first, that part goes on next. Like I said, it's a little tricky, especially when you're trying to film this. And now you're gonna basically put this other part of the ball joint on, so that it's held on before you actually attach the little thumb clamp. Here we go. And you can tighten this just so that it's kind of out of the way for right now, but it's still affixed to the box. So now the solar panel's on the box, and the solar panel, if I put some light on it, is actually charging the Solar-Lipo as well. Here's my wire. I've got a little bit of slack in that so that I can move this around anywhere I want. So that makes things much easier. Okay, and now the final part of attaching the solar panel is actually putting a little wraparound conduit on this cable to keep it safe from rodents and the sun and everything else. So this stuff is pretty cool. It's a little bit expensive. You only need about 6.5 inches of it to make it work. But you'll see that they're basically two pieces of conduit that kind of wrap around each other. So what I'm going to do is I'm going to pull the inner conduit out, and that's the conduit I'm going to put on the wire first. Easier said than done. Kind of at a weird angle here because of the iPad that I'm using to film this. So this looks difficult, but it's a lot easier when you're not trying to film it. There we go. And now you just take this other stuff and you just kind of clip it on. Not too bad. And that's going to create a nice housing for that wire. Keep it safe from animals. Keep it safe from the elements. There we go. There, that looks good. Okay, so as you may have noticed, these cable glands coupled with this conduit don't make the cleanest fit right there. So one way to work around this, and I'm open to suggestions on this front, is to use a little bit of electric tape to tighten things up around that fitting. And this will hold. I had one of these units in the field for 2 years, and this electric tape does hold pretty well, but at least it covers up that red cable, that red power cable, from being exposed to the elements, and also drawing attention to rodents that might be attracted to that red color. It's not very pretty, and I'm open to ideas to make this look a little more professional, but it does work. And again, ideas are welcome on how we can make this a little cleaner, but this will keep that wire from being exposed to the elements. So another option for the wraparound conduit, if it's giving you a little bit of trouble, because it can be a little tricky to put on and a little time intensive, is just to use one piece of the wraparound conduit. Don't use both pieces. And you just cut it down to size, and then you just fit the wire inside the conduit. This goes much quicker. See, we're done. You'll get a little bit of exposure of the wire where it splits, but the other thing you can do then is just take some electrical tape and wrap this up in electrical tape, since we're using electrical tape anyway to kind of finish off the ends. And that's one more way to kind of provide some protection to this red wire coming off the solar panel to the elements and to rodents. Attaching the battery to this box is pretty simple. What I typically do is just put a little bit of Velcro onto the back of one of these LiPo batteries and just attach it to the base plate. Then of course you want to take the power coming off of the battery and you want to put it into the battery terminal on the Solar-Lipo Charger. And then the last thing is you want to take the thermistor and you want to attach it to the battery. And what that's going to do is ensure that if this battery gets too hot, that charging to the battery will be cut off, because these LiPos can catch on fire if they're charged at a temperature that's too high. So this is kind of a safety measure. And for the thermistor, all I've done basically is attach it with a little bit of electrical tape. Okay, so the next thing we'll want to do is attach the stick-on antenna to the Fona, and you can see there that there's this little socket that will accept that part of the stick-on antenna. When you're ready, you just basically line up the two parts and kind of evenly push down, and it should snap right into place. Okay, and the next thing we need to do is connect pin 10 on the Fona to the key pin. So the way we're going to do that is we're going to cut about 4 inches of this jumper wire, and once you've cut it, go ahead and bend one end of it at about a 45-degree angle. It's easy to do. This probably would have been easier if I did this earlier in the setup. But then you take that bent part and you count 6 pins up on the left-hand side of this terminal block. 1, 2, 3, 4, 5, 6. Let's go ahead and open up that terminal block. And then what you're going to do is feed one end of your stripped jumper into that little terminal block. We're going to close it. And then you take the other end and you put it in the very last pin on this side, in the very last plug, which is the key pin. And again, if this is giving you trouble, you can always insert this earlier in the build. But what this is going to do is it's going to allow us to turn the Fona on and off within the software. As long as we've cut that trace on the key pin pad, which I mentioned earlier in the video, now we can actually control the power state of the Fona from within the software, which is going to help us save some power. Now we can take our Feather with its antenna, plug it into the terminal block, and then we can take the power from our Solar-Lipo Charger, put that into this little plug right here. And when you do that, you might see a few lights coming on and off. Do make sure that you check the switch that's in the back of the Feather terminal block right here. There's a little on-off switch right here. Make sure that that is set to on if you want the Arduino portion of this thing to work with your Fona. If that's off, it's not going to run the sketch. So do pay attention to that switch in the back. Make sure that it's set to on. And you can see that on is to the right if you look closely in the video. And right now, I just have the blink sketch running as the default on the Fona. So you may be wondering, is the point of this quarter-size perma proto board that we included in this build? Well, this is useful for running power from your Feather Fona to an area where you can, say, hook up an LCD through a user-friendly header, or maybe attach a capacitor for filtering noise to a sensor. In short, you don't have to include or use this proto board in your box, but it's nice to have when the need arises. And I'll show you an example of where I've used those little proto boards. In this case, I have an ultrasonic sensor that gets powered off this little terminal block right here. And since ultrasonic sensors can be a little touchy, I've included a little noise filter via this capacitor on the power rail. And then I've also got this little header, which makes things a lot easier for, say, hooking up an LCD when I'm in the field to see how the algorithm on the phone is executing. Also, please note that the solar-powered enclosure and this Featherwing terminal block breakout that's offered by Adafruit can be used with any of the Feather form factor boards. All you do is just unplug the Feather that you're currently using, in this case the Fona, and just replace it with any other Feather that you're interested in. Say you're interested in data logging in the field, so you could use this ADA logger that allows you to record environmental conditions to this little SD card slot right here. And then you can remove the SD card when you're in the field, replace it with a new one, take the SD card to your office, download it, and plot your results in Excel. In a future video, I'll explain how to add a sensor to this build, and then I'll modify the code shared in my Introduction to the Internet of Things video to measure presence, absence of flow in the field, and then show you how to report the same to a ThingSpeak channel. Thanks for watching, and stay tuned for updates.